Welcome to this explainer. Let's just jump right in. Today, we're embarking on a journey to decode a massive mathematical universe, specifically the real numbers family. You know, if you've ever looked at a page of math and felt like it was just this chaotic jumble of digits, well, you're in for a treat, because beneath the surface, there's actually an epic family dynamic at play here. We're talking about a system that governs everything from the loose change in your pocket to the very shape of our universe.
But before we zoom all the way out to look at the entire family tree, let me just ask you this. What makes a number truly irrational? It's a term you've probably heard thrown around. Maybe you've even used it to describe a friend's behavior, right? But in the mathematical universe, irrationality has a very specific, honestly mind-bending definition. Let's find out exactly what that is. To make sense of all this, we're going to follow a pretty straightforward roadmap. We'll start with the real numbers family, look at the predictable rational numbers, then their siblings, the wild irrational numbers. After that, we'll have a decimal showdown, do a little plotting on the number line, and finally, look at math in the real world.
Okay, Section 1, the real numbers family, the big picture of our number system.
Moving to Section 2, the predictable rational numbers, neat, tidy, and rule following. And Section 3, the wild irrational numbers, infinite and rule breaking. Okay, let's dive into this. When we look at these two factions of the number family side by side, the fundamental difference really comes down to a simple fraction. A rational number, our predictable sibling, can always be neatly written in the form of p over q. That's where both p and q are integers, and q absolutely doesn't equal 0. Think of simple fractions like 3/4 or -2/5. Even regular integers like -3 totally work, because, well, that's really just -3/1. But in a rational number, that's the chaotic side of the family. It strictly cannot be written in that neat p over q format. It's literally mathematically impossible.
All right, Section 4, the decimal showdown, how they look on paper.
Check out this comparison of their decimal behavior. Rational numbers neatly terminate or they repeat. For example, 1/2 is exactly 0.5. Boom, it stops right there. Or, if you take 1/3, you get 0.333 repeating infinitely. Sure, but in a very predictable, orderly pattern. Irrational numbers, on the other hand, they are completely non-terminating and non-repeating. There is absolutely zero pattern that repeats. Take the decimal for pi. It's 3.14159, and it just keeps going, forever. This is exactly why you can never perfectly mathematically divide a pizza using pi. Or look at the square root of 2, 1.4142, it never ever settles into a repeating loop. It is total mathematical anarchy. Section 5, plotting on the number line, finding their place. Now, what's really fascinating is how we're forced to represent these numbers visually. The rational numbers like -3, -0.5, 0, 2.75, they get exact, solid blue dots. We know precisely where they live on this line. But the irrational numbers, things like the square root of 2, pi, or the Bolden ratio, they just get an x. And that's because their decimals never actually end, so we can only ever pinpoint an incredibly close estimate of their position. We literally can't nail them down perfectly. Which brings us to Section 6, math in the real world. Where do we actually see them?
You know, you might think these infinite decimals only live in dusty textbooks, but they actually define our physical reality. Pi is literally the soul of every circle. You need it for the circumference and the area. The square root of 2, it's physically built into the diagonal of any perfect square. Euler's number E is the absolute backbone of calculating continuous growth like compounding bank interest or population growth. And the Golden ratio dictates things like the spiral of galaxies and the geometry of flower petals. These wild, irrational numbers are essentially the blueprints of the universe. We absolutely need them.
So the crucial point is this. Remember, all rational and irrational numbers together form the set of real numbers. Despite their massive differences, one being neat, exact, and terminating, while the other is infinite, non-repeating, and totally chaotic, they aren't actually enemies. They're basically two halves of a whole. Together, they create this complete, unified system that we rely on every single day to measure our reality. Which brings us to a final thought. Next time you measure a circle, or check the diagonal of a room, or even just look at your bank account, ask yourself, are you looking at a neat, predictable, rational number, or is there a wild, infinite irrationality hidden just beneath the surface? Thanks for joining me for this explainer, and definitely keep exploring the incredible numbers all around you.